Every day, millions of people turn on a tap and water comes out. What they don't see is that this water may have traveled over 1,000 miles, crossed deserts, climbed mountains, and passed through tunnels deeper than skyscrapers or tall wall before reaching their sink. This isn't nature. This is engineering forcing geography to cooperate. Welcome to the world of Mega-Aqueducts, hidden lifelines of modern civilization. Here's the fundamental problem every civilization faces. Water doesn't exist where people want to live. The world's largest cities are often built in dry basins, coastal plains, deserts, or regions with unreliable rainfall. Meanwhile, fresh water sits hundreds or even thousands of miles away, locked in rivers, mountains, or distant reservoirs. Rain alone can't support cities of 10, 15, or even 20 million people. So engineers did something radical. They decided to move water instead of people. Some of the world's largest aqueduct systems stretch over 1,000 miles. They include open canals wider than highways, underground tunnels drilled through mountains, and pumping stations powerful enough to lift water hundreds of meters uphill. In places like the western United States, China, and parts of the Middle East, these systems deliver water to over 20 million people every single day. This isn't a single structure. It's an entire artificial river, engineered and controlled. And gravity alone isn't enough. Water naturally flows downhill. Mega-aqueducts don't always have that luxury. To cross mountain ranges and plateaus, engineers built giant pumping stations that push water uphill, sometimes hundreds of meters above sea level. Each pump consumes massive amounts of electricity. Some systems use more power than entire cities. And if the power fails, water stops, which means cities stop. This turns water delivery into a national security issue, not just an engineering one. Building these systems costs tens of billions of dollars. Maintaining them costs billions more. But money isn't the biggest challenge. Politics is. Mega-aqueducts divert water from farming regions, indigenous lands, and fragile ecosystems. Rivers shrink, lakes disappear, wetlands collapse. Entire regions argue over who gets water and who loses it. In some cases, these projects saved cities, but permanently damaged the landscapes they pulled water from. This creates a brutal question. Who deserves water when there isn't enough for everyone? These systems were built decades ago. Some are now aging, cracked, and overstressed. Earthquakes, climate change, drought. If a major aqueduct fails, millions can lose water within days. No water means hospitals shut down, power plants stop, and the food supply collapses. Mega-aqueducts are miracles, but also single points of failure. Civilizations that depend on them are strong and fragile at the same time. Mega-aqueducts don't make headlines. They don't look futuristic. But without them, modern cities simply cannot exist. They are proof that humanity can bend nature, but also a reminder that nature always sends the bill later. Every time you turn on a tap, remember that water didn't arrive by chance. It traveled across a continent because engineers made it. If this changed how you see cities, subscribe, because the most powerful structures on Earth are the ones you never see.